Hello guys, welcome. Today I'm talking about the Avr programmer. That's the Avr USB ASP, and then you're using it to program the Avr microcontroller. That's the attiny, and then you have the Atmega series. This is the attiny 85. You can use attiny 13, and then you can also use the Arduino IDE to develop a microcontroller project instead of like using an Arduino. Let's say you don't have an Arduino, you can just use this. So this is a homemade board. You see, this is a strip board that I used, and even it's very homemade. You can see, there are no traces, it's not etched, it's just soldered, hand soldered, homemade, pure classic. So this is the LED here. This LED is connected to pin 13 as usual. You can see pin 13 on the circuit diagram of Atmega 328P. Your pin 13 is the one, pin 13, it's the one that is the serial clock. So pin 13 in the actual microcontroller is pin 19, and pin 12 is in the actual microcontroller pin 18. So this is the meso, the MOSI clock. These three pins plus reset are very important when connecting the programmer, because like if you look at your programmer, you have the MOSI, master out, slave in, NC no connection, VCC, and then you have the GND, you have the meso, master in, slave out, and serial clock reset. You see, you have to connect all those pins like as shown here. There is the reset pin, this is the MOSI, this is the meso, and then you have the serial clock for this SPI interface. So you have to make this board as simple as this. You have to put the ground and then have a 10 microfarad capacitor to decouple the line, and then use a 16 megahertz crystal. This is essential for the Arduino library. And then you can put this reset button here, which of course in my circuit I don't have that. I don't need that because I don't have to reset it. I'm just using this to develop my project. So you can use a button, you can add a button there, or you can just use a 10k resistor to pull it up from VCC to reset. You're pulling up the pin to avoid it from getting reset, because when you press it, it goes down low. So you're resetting it, it's reset low. So guys, these are simple thing, and sometimes these things can be a little bit tricky. I found them a little bit disturbing when it's looking for drivers. Some drivers, especially for Windows, Microsoft, it's a little bit disturbing on drivers. But if you don't find drivers, I'll advise you, unfortunately you have to go to something like Linux. Like I'm using Linux Mint, and it works very fine. On Windows I couldn't find the drivers. They told me the drivers were outdated, so I switched to Linux, and it's working so fine. So guys, all you have to do is in this orientation, one thing, you have to just slot this thing here, yeah, like it's slotted there. And then let me go to the computer, and then I show you how to program this thing to blink. Later on we'll see how to use the smaller microcontroller to also blink the LED. Same, this LED as said is connected to pin 13, so I'll address that pin 13 in my variable. Okay, now that we have the small guy on board and the big guy out, now this is the attiny 85 microcontroller, and then we have the programmers connected, so there's nothing, it's not blinking because we haven't uploaded any program to that thing. So what you have to know is that using the attiny, you have to change some few settings, like you have to change, if you try to upload this directly. Let's try to upload this using a programmer like is that a sketches. You use a programmer. You see, it's telling me that wrong microcontroller found. Did you select the right board? So it won't upload because previously we were using at Mega 13 and not at Mega 13, at Mega 328. So we'll have to go to tools, and we have to select the board. The previous ones was this chip for the one that in Arduino IDE. So you have to change the chip. You have to go to the board select. You have to include, check the attiny series. This is attiny 855. I'm looking for 8485 right there. So I have to also check now it's attiny 85 processor speed. You can change all these settings. You see mills accuracy. Remember, we're not using the crystal this small guy. We're using direct internal crystal oscillator, so you have to make sure like this thing is 3.4 volts. That's what the programmer we are using at that volt. These other settings, the accuracy, you see it's 1.66% error default. So you can also use the mills tone, and then we have the mills and tone functions which might be available or not available depending on the settings you'll set here. So after doing all that, you have the USB ASP in your list of programmers. These are USB ASP selected, and now let's upload it. Go to sketches. Now let's watch it as I'm uploading it using a programmer. Let me upload, watch as it go crazy. Now there it is, it's blinking, and there it will show you done uploading. As simple as that. So you can even use this microcontroller to interface an LCD screen, but then you have to use the I2C interface because these pins are so few. Obviously you can't get all the pins of the LCD from this chip, so you'll use the 2 pins for I2C. You can even save data and display it, and then you can do small project for like using shift registers. You can use this shift registers with shift registers, and then you can make a large LED array. I found it nice. Even you can use the small tiny 13 to do small projects for like LEDs, and it's awesome. This is cheap. They are also good to use. The good thing with this big guy has a lot of pins, and then has a larger memory, and that's all guys. So these are, you can make your homemade programmer at home, and thank you guys for watching. See you later.